Hello there, I'm Liam Dean. I founded FP English. FP stands for First Principle. I may be the first Taiwan YouTuber who can express, appreciate, and integrate knowledge of engineering subjects of the university. This is the first episode, and I want to talk about ODE of first order. ODE stands for Ordinary Differential Equation. Basically, this episode, or should I say the whole series, is intended for people who are required to have basic understanding of ODE with English of a medium level or above. The textbook for reference is listed below. Let's start with this paragraph. Chapter 1 begins the study of ordinary differential equations, ODEs, by deriving them from physical or other problems, modeling, solving them by standard mathematical methods, and interpreting solutions and their graphs in terms of a given problem. The chapter ends with a study of the existence and uniqueness of solutions of ODEs in section 1.7. So the number 1, 2, 3 in the red circles indicate the sequence of how we apply ODEs in solving the physical problem. Let's review one by one. Number 1 says, deriving ODEs from physical or other problems, which is modeling. Modeling is that we try to translate the physical situation to a mathematical model. An example is given as below. We have a stone falling from a tower, and if we denote y as the displacement of the stone relative to the top of the tower, then y double prime means the acceleration of the stone, and g means the gravity. So y double prime equals g is probably the simplest form of ODE. But with the hindsight, we have to ask, is air resistance considered? We know that if the ball gets bigger, thus the surface area gets larger. Or if the tower is higher, thus the terminal speed of the stone also gets higher. Therefore, the air resistance will also get higher until a point where it can no longer be ignored. And again, with the hindsight, a term representing the air resistance can be depicted as c times y prime. C is the constant, and y prime means the velocity of the stone. Therefore, during the modeling, we encourage the learners to ask the right question, or should I say, the insightful questions. Have we considered all the variables which should be put into the ODEs? Are every constant in the ODEs carefully chosen or calculated? Okay, let's go back to the paragraph. Number 2 says, solving ODE by standard mathematical methods. This is probably something that we are familiar with because when we are students in the school, we are trained to solve the ODEs as quickly as we can, as accurately as we can. But nowadays, this calculation work can be given to the computer. So that's why for FP English, I try to ignore the calculation and we will focus on the modeling and the interpretation. So thirdly, interpreting solutions and their graphs in terms of a given problem. So here an example is given as below. There is an exponential decay curve for atoms in a radioactivity. As per the curve, we can see that the mass of the atoms decrease at an exponential rate. And if we substitute a specific time into the mass function, we can calculate how much mass is left. So that sort of thing is what we call interpretation. Again, let's review this paragraph with a different focus. Chapter 1 begins the study of ordinary differential equations by deriving them from physical or other problems, blah blah blah. Here we can see the textbook choose the verb begins as the transitive verb because there's no preposition here in the sentence. But interestingly, we can notice that the textbook chooses the verb ends as an intransitive verb because obviously there's a with, the preposition with, here in the sentence. So what's the reason behind this two different choices? If we choose the verb begin as the transitive verb, like the textbook does, the main sentence will be this yellow marked sentence. Chapter 1 begins the study of ordinary differential equations, ODEs. This is the main sentence. And number 1, 2, 3, these three parts will be used to modify this main sentence. On the contrary, if we choose the verb begins as an intransitive verb, and of course we have to put the preposition with here in the sentence, then the main sentence, which is the yellow marked sentence, will be like this. Chapter 1 begins. This is the main sentence. So, with the study of ordinary differential equations, this part will be used to modify this main sentence. And likewise, number 1, 2, 3, these three parts will be also used to modify this yellow marked sentence. So, by this comparison, I hope you can notice the subtle difference between these two choices. And furthermore, I hope you can get the same feeling as I do, that the choice of begins as a transitive verb for the upper paragraph is better and preferred. Let's review this paragraph. If we want to solve an engineering problem, usually of a physical nature, we first have to formulate the problem as a mathematical expression in terms of variables, functions, and equations. So here it says, if we want to solve an engineering problem, usually of a physical nature. When we say something of a physical nature, it means something having the character or qualities of physics. And here it says formulate the problem as formulate means to turn something into a formula. And here, number one, variables means x or t time, or number two, functions means y of x or y of t, and equations means the differential equation, which is y prime equals f of x and y. For example, y prime equals 9 times y plus the exponential constant to the power of minus 2 times x. Hence, a model is very often an equation containing derivatives of an unknown function. Like this example, we have y prime, which is the first derivative of y. We then want to find a solution, a function that satisfies the equation. A function that satisfies the equation means that there is a y of x which can satisfy the equation y prime equals f of x and y. Finally, and interpret it in physical terms so that we can understand the behavior of the physical system in our given problem. Since we get the solution, which is y of x, we have to interpret it. What is y of x? What does y stand for in terms of physics? What does y prime stand for? What does x stand for? What does the curve of the y of x stand for? That is the interpretation. So we know the behavior of the physical system in our given problem. So throughout this paragraph, again, it indicates the 3 steps process of the application of ODE in physical problem, which is formulate the problem as a mathematical expression, which is modeling, and then we want to find a solution. This is solving the ODE, and finally we interpret it in physical terms. This is interpretation. Let's review this paragraph. A function y equals h of x is called a solution of a given ODE. F of x, y prime equals 0, and the open interval x between a and b if h of x is defined and differentiable throughout the interval, and is such that the equation becomes an identity if y and y prime are replaced with h and h prime respectively. First of all, I want to say that open interval x between a and b, this interval excludes point A and point B. On the other hand, closed interval includes point A and point B. Secondly, if y equals h of x is defined and differentiable throughout the interval, and this essence of h of x makes the equation becomes an identity. Which means that if h of x is defined and differentiable throughout the interval, then this equation f of x, y, and y prime equals 0 will becomes an identity. It means no matter what x is, the function f will always be 0. Of course, you have to remember to substitute h and h prime into y and y prime. You have to remember that. So here it says if y and y prime are replaced with h and h prime respectively. That is a reminder. The author of the textbook don't want you to miss any links in your reasoning process. And from the perspective of grammar, some words must be omitted here in the sentence. And what do you think that is? At the first thought, you might think it's h of x, like I did. But at the second thought, I think h of x alone is not enough to make the equation becomes an identity, because h of x has to be defined and differentiable throughout the interval. So I think what's omitted here is this whole sentence, this sentence, and which represents the essence of h of x. So maybe I should say what's omitted here is it, and it is a dummy subject, 虚主词, which represent this part of the sentence. Okay, let's take a look at a typical form of ODE and its solutions, which are exponential growth and exponential decay. On the left-hand side, this family of curves represent exponential growth. You can see that the y value increase at an exponential rate. And on the right-hand side, this family of curves represent the exponential decay. You can see that the y value decreases at an exponential rate. And y prime equals k times y is the typical form of the ODE. There exists a general solution, y equals c times the exponential constant to the power of k times t. You can easily observe and verify the result by substituting y into the ODE, and c is an arbitrary constant. Let's review this paragraph. In most cases, the unique solution of a given problem, hence a particular solution, is obtained from a general solution by an initial condition, y of x0 equals y0, with given values x0 and y0. That is used to determine a value of the arbitrary constant c. Geometrically, this condition means that the solution curve should pass through the point x0, y0 in the xy plane. An ODE with an initial condition is called an initial value problem. So in the first point, here is the Chinese translation. Especially, I say 代入通解. This 4 Chinese characters are marked in red because I have the hindsight. I know this particular solution is obtained by substituting an initial condition into the general solution. Otherwise, judging by the original paragraph, I think that it says obtain from a general solution. Sounds quite abstract. What does it mean by saying obtain from a general solution? Does the particular solution transform from this general solution, or do we cut the general solution in pieces and take one of them? So what I'm trying to say is it sounds quite abstract. So with the hindsight, I rewrite the original paragraph into this one in the lower part of the slide. It says a particular solution is obtained by substituting an initial condition y of x0 equals y0 into the general solution. That is used to determine a value of the arbitrary constant c. So I think by writing like this, the relationship between cause and effect becomes very clear, because substituting the initial condition into the general solution is what we have to do to get the particular solution. That leaves no room for ambiguity. Let's review this paragraph. An ODE may sometimes have an additional solution that cannot be obtained from the general solution, and is then called a singular solution. When a differential equation is solved, a general solution consisting of a family of curves is obtained. For example, y prime squared minus x times y prime plus y equals 0 has the general solution y equals c times x minus c squared, which is a family of lines. Up to this point, we don't know how the general solution to this ODE is found. We're just given with this solution. And we can observe that it is a family of lines by substituting different values of c. Then y becomes a family of lines. Then what about here it says a general solution consisting of a family of curves. We have to notice that straight line is a degenerate form of curves. I'm not going to provide a strict proving process here, but just remember that straight line is a degenerate form of curve. So the general solution is a family of lines. If we take a look at the graph here, we can see there are 6 straight lines. And here it says the parabola y equals x squared over 4 is also a solution of the differential equation, but it is not a member of the family constituting the general solution. This parabola, you can see all these 6 straight lines are tangent to this parabola. That is why it says the singular solution is related to the general solution by its being what is called the envelope of that family of lines representing the general solution. Oh, such a long sentence. Let's dissect the sentence and analyze it. The singular solution is related to the general solution. So what kind of relation between singular solution and general solution is that? This relation is established by singular solutions being the envelope of that family of lines. It says that the singular solution has to be the envelope of that family of lines. What does it mean by envelope? Envelope is what I mentioned previously, that all these 6 straight lines are tangent to the parabola, and that makes this parabola, which is the singular solution, the envelope of this family of lines. And this family of lines, don't forget, they represent the general solutions. So, singular solution is the parabola which intersects with the origin, and it is the envelope of this family of lines because all these lines are tangent to this parabola. Okay, let's review this paragraph. It is also about singular solution. And this is an excerpt from some website. When a differential equation is solved, a general solution consisting of a family of curves is obtained. For example, y prime square equals 4 times y. Here's the general solution. Y equals x plus c squared, which is a family of parabolas. Okay. And does anyone have question about why a general solution is always a family of curves? Because you can see in any general solution of any ODEs, there is always a C as a multiplier in a solution. So if you substitute different value of C into the general solution, of course you can get a family of curves. So this general solution is a family of parabolas, and the line y equals 0 is also a solution of the differential equation, but it is not a member of the family constituting the general solution, which means that the line y equals 0 is not a member of this family of parabolas because it is a straight line. An envelope is defined as the curve that is tangent to a given family of curves. We have talked and introduced this in the last slide. And if the singular solution is an envelope, it can be found from the general solution by solving the problem and finding the value of the parameter c, for which y has a maximum or a minimum value for a fixed x. And then, okay, let's stop here. So, in order to find c, and please remember here c equals c of x because we want to substitute this c into the general solution in order to get the singular solution. So the word parameter c, parameter indicate that c is a parameter or c is a variable for which y has a maximum or minimum value, which indicate that if we want to find this parameter c as a variable, we need to find the derivative dy over dc equals 0. That's where y has a maximum or minimum value. And so by calculating dy over dc equals 0, we have 2 times c plus x equals 0, so we get c equals minus x. Don't forget that x is considered as a fixed value. So we have c as a c of x. And then we substitute in this value for c back into the general solution, like that I told you previously. So we plug c equals minus x into y. So into the general solution, because c equals minus x, so y equals 0. So this straight line, y equals 0, is the singular solution, and which is also the envelope of this family of parabolas. You can see that each parabola is tangent to the straight line y equals 0. Okay, up to now you have seen all the slides which are which seems very wordy, very visually overwhelming, because these slides are full of word and graphs. And now, because I'm going to provide you with some takeaway points, so from now on, I will make those takeaway points very short and simple, in order to make you visually comfortable. And also, I want you to get a feeling that these takeaway points are so light that they can be put in a small luggage and you can take and go. So the first point is, the first takeaway point is, it's glad that we know the 3 steps in ODE problem: modeling, solving, and interpretation. This point we have been emphasizing throughout the presentation. So the first step, mathematical modeling, and third step, physical interpretation, is something I want to focus on. And the second step, mathematical solution, I believe most of the students have been trained, or should I say tortured, by school or cramped school, because they devote themselves in repetitive calculation and practice. And actually, this calculation and computation work can be assigned to computer. So that is why I want to ignore the second step, at least to some extent. The second takeaway point is, we have introduced how to find solution, but the condition of it, the method of finding a general solution will be introduced in the subsequent chapter or subsequent sections. But now, the point that I want you to take away is that we know the condition of the solution, which is the premise. That is, if y equals h of x is defined and differentiable throughout the interval. That is the condition we must satisfy before we can find a general solution. The third takeaway point is that we introduce you with the exponential growth curve and exponential decay curve. And we introduce the typical form of ODE, which is y prime equals k times y, which means that the slope of y equals is proportional to the y itself, and there exists a general form in the form of c times the exponential constant to the power of k times t. The fourth takeaway point is that a particular solution is obtained by substituting an initial condition y of x0 equals y0 into the general solution. It's called initial value problem. And finally, geometrically speaking, a singular solution is an envelope of the family of curves representing the general solution. Finally, in the end of this video, I want to leave you with an open question. When I say open question, of course, it's not an yes or no question. I believe an open question will encourage and facilitate your expression in English. So this open question goes like this. Can you elaborate on these 5 takeaway points in English, either by detailed explanation or giving examples? You can either use the tutorials in this slide, or you can use the textbook that I listed on the cover page of this slide. I think you can use both materials to help you to elaborate on these 5 takeaway points. And I will be happy to work with you whenever I'm available. We can make appointments for online meeting or face-to-face meeting if you live in Taipei. I want to improve your fluency. I want to make sure that you can express yourself smoothly with a decent structured sentence, with correct and professional mathematical terms. So let's meet. I leave my FB page, line ID, and email here. So feel free to contact me. See you next time.